Welcome, everyone. My name is Mark Hughes, and I am part of the team at Advanced Assembly in Aurora, Colorado. I would like to thank everyone for taking time out of your busy day to join us for this webinar. For your convenience, we will record this webinar and send it out to you in a few days. We heard your requests at our last webinar, and we're here to answer your questions about DFM and DFA. Please ask them in the Q&A box, and we will either answer them as we go along or at the end of the webinar. Now for our presenters. Elijah Gracia and Chao Vang. Elijah Gracia works at Royal Circuit Solutions, a PCB fabrication house, and Chao Vang works at Advanced Assembly, where boards are stuffed. Elijah is the lead engineer at Royal Circuit Solutions in Hollister, California. He's been working for Royal for 6 years, perfecting the science of PCB fabrication. Chao Vang is an engineer manager at Advanced Assembly in Aurora, Colorado. Chao has been assembling boards for 10.5 years. Both presenters encounter problems that stop boards from being built dozens of times a day. So we are here to learn from their experiences. The presentation is divided into 2 parts, PCB fabrication and PCB assembly. So to find out how to streamline the build process on your next design, here are Elijah and Chao.
Hey everybody, I'm Elijah from Royal Circuit Solutions. We're a PCB fab shop in Hollister, California, and we're specializing in next day turns and complex boards, including rigid flex, and flex PCBs.
Hi everyone, my name is Chao and I work for Advanced Assembly. We are a Colorado-based company specializing in quick turn SMT assembly. We've assembled more than 45,000 unique designs in the past decade and are continuing to grow.
Awesome, so let's get right into it. Today's big question, what is DFM and DFA? So DFM stands for Design for Manufacturability. And when we're talking about DFM, what we're focusing on is the actual design of the circuit board. Basically, we're running a form of spell check, which is able to answer the question, can the circuit board be fabricated with an acceptable level of risk? And then there's DFA, which is designed for assembly. So as the name kind of suggests, is we're now focusing on the layout of the components that are going to be placed on the circuit board during assembly. And by running these DFA checks, we can answer the question, can the parts be successfully mounted? And although there's a high probability of success at this point, a mistake can be expensive for the customer and for the assembly house. So just a quick little overview of what we're going to be going over today is some common holds and delays that we can hopefully clear up now to avoid placing your order on hold in the future. And we're also going to be going over a few design guidelines and some fabrication issues. Then we're going to be switching over to the assembly side and cover some common assembly issues that we have. And after that, we put together a quick list of some basic do's and don'ts in the industry. Again, that's just to help keep your orders moving without any hiccups. And last, we're going to open it up to any questions you might have for us. So let's get right into it. Let's talk about hold and delays and the process we use for hold and delays. And really quick, the reason we want to avoid holds is because if we have to ask you a question, depending on the time of day and the availability, this hold can take anywhere from 5 minutes to a few days at times, and we really don't want that happening. So really quick, how are errors being discovered and why are we holding your orders? Usually at the time of quote, we're able to plug your files into a DFM and DFA software, which like I mentioned, it's kind of a spell check for your design and your assembly process. The software we use is able to find all the big and small problems based on the rules that we apply to it. And at the end of the check, we're able to give you a report on anything we're going to have issues with during the build. If you look at the example on the left, if the spokes on your thermal pads are too thin for the software, it's going to catch it, and then we're going to get that issue fixed right away. And the whole point of this is if we're letting you know about it, it's a 5-minute fix on your side, and we're avoiding that multiple hour or day hold, and we can keep your board running through the shop without any hiccups. Chao, do you want to talk about the DFA holds?
Yes. On the assembly side, we discover the errors by performing the DFA check on our proprietary program. We use your bill of materials, your XYRS, and your Gerber layers. And then we're comparing the BOM to the XYZ and vice versa, finding discrepancies between the two files. We're also using package models to overlay on your footprint, looking for layout issues. And how we actually contact you is via email. We'll give you a list of all the issues and concerns that we have. We'll send that to you along with a few of our smt.pdf files for your visual aid in assisting you to review all the holds. And we'll just need your feedback on how to proceed in order for those holds to go away.
Awesome, thanks, Chow. And let's go over a few simple design guidelines to help you out. First thing we want to mention is the fabrication guidelines. Any board shop that you use is going to have their own specific guidelines to follow based on that shop's capabilities. So be sure to get that list so that you're setting yourself up for success from day one. If you're using Royal Circuits, we kind of have a huge list of design rules that we use depending on what kind of specs you're trying to achieve. And I can't stress enough how valuable these documents are. They're going to save you and us a lot of time by just, again, giving you what we should be starting with from the very beginning. Another useful tool that we provide is our minimum trace and space chart. On the left side, you can see if we look for the copper weight that you're going to be using, you can follow that minimum trace and space rule. There's a slightly different set of rules based on inners and outer layers. We're able to get tighter gaps on your outer layers than we are on the inners, but we can usually meet the design needs just by changing copper weight sometimes. But again, if you follow this from the very beginning, there's not going to be any surprises, and we're going to get your job running smoothly through the shop. And again, just to clarify, these are the minimums. So you should be trying to use something larger than this trace and space whenever possible. That's going to increase your yield per panel because lower risks mean lower cost per board. Now let's talk about some of the common fabrication issues that we see here at Royal Circuits. These are all very minor issues and they can be cleaned up and clarified before we even see your Gerbers. And that's going to help keep your job running smoothly, again, like we're talking about. So this first example is something I see every week as an engineer, and that's something as simple as the customers not specifying their plated and non-plated holes in the design. And as easy as that might sound, it does get missed a lot. In the example below, you can kind of see those 4 black holes, which look like they should be non-plated. All the other holes look like they should have plating. They have that yellow copper around it. But if a customer doesn't provide that drill chart and telling me which holes are non-plated and which holes are plated, I'm going to be placing this job on hold because I don't want to make an assumption and be wrong. Sometimes customers do provide those drill charts and they're wrong. They might say that something is non-plated and everything that I'm looking at says, no, it should be plated. So I'm going to put that on hold. So always give yourself a double check if you are sending those drill charts. The next issue is something we see a lot, something called hanging traces. This is basically a trace that was created, but they don't actually go anywhere or have a purpose. And this might be an extra feature that won't affect the board, but on the other hand, the customer might have accidentally deleted a hole or a trace that would have completed this connection. So we can't assume on our side that we know what you're trying to achieve. So we're definitely going to put this job on hold. Another simple issue to fix is the copper to board edge. On the left side, we can see that copper is running all the way to the board edge. And the problem with this is when we cut out the board, you're going to have copper exposed along the edge of the board. This can be intentional, but it might not have effect on a board, but it can also ruin a board in some cases. So we're not going to take that risk. We're going to place it on hold and ask if you did this intentionally, because sometimes, again, it won't matter. But we're going to ask if we can possibly clip it back like you see on the right side. That's going to save everybody from a lot of trouble. And another common hold that we see would be the solder mask openings. On the left side, we're going to see those yellow pads that are smaller than the red copper pads. And that's the solder mask clearance. In most cases, we expect to see the solder mask larger than the copper pad. But some designs do require something we call solder mask defined pads, and that's what you're seeing here. So as I just mentioned, that can go either way. And it's not something we're going to assume on our side, because if we're wrong, it's going to cost us money. If you're wrong, it costs you money in remaking the board. And so, yeah, there's another hold. And then the last issue I'm going to show you is probably one of the most common issues, but also one of the easiest fixes on your side, and that's the annular ring issues. The image on the left shows the yellow holes and very little copper around that hole. The less annular ring we see, the more chance we're going to have a breakout, and that's what you're seeing on the right. So anytime you're able to increase the annular ring to at least 5 mils or greater, that's going to help you out a lot and help us keeping your board running smoothly. And I'm going to hand it over to Chow to talk about assembly issues.
Thank you, Elijah. Okay, so the first issue that we actually see after we import the bill of materials is repeated reference designator. And this can happen for a number of reasons. It could be due to the software that you're using, it doesn't increment correctly, or if the copy and paste that you're doing is not correct. And so looking at these examples here, you see L4 and L5 repeated on there. So basically we're just asking you, is L4 supposed to be populated with that component listed, or is it supposed to be DNI? Or if it's a completely different part, I need you to identify it at this time. So we need to know if L4 is populated or DNI, and the same with L5. So we'll capture that in the list of holds and send it to you to review. The next type of issues that we actually see when we're importing the bill of materials and then the XYRS is the comparison between the two files. So the first, looking at the examples, the first list there shows you all of the components that are missing from the XYRS files, but they were found in your bill of materials. And then the second set there is actually the components that were found in your XYRS and missing from the BOM. So this gives you the opportunity to say, hey, I really want C25 on my build. Can you add it in? Here's the part number. So it's giving you the comparison, and you're going to tell me if yes, those are parts are DNI, or no, go ahead and populate it. Here's the part number, or here are the coordinates where that part is supposed to go. And again, this is going to be listed on the list of holds to you for your review. Another critical check that we do in the DFA is to look for value discrepancies for resistors and capacitors. We're taking the manufacturer's part number that you have in your bill of materials, going out to the internet or database like DigiKey or Mauser, and then pulling up the values that's associated with that part number. And then based on that value, we're going to go back to your bill of materials and compare that with the value you have it listed there. Our main concern at this point is just to say, do those match? So at this point here, if they actually do, then we're good to go. If they don't, we'll capture the hold in a table like the example shown there for you. And we're going to ask you which value is correct to proceed with each line item. And so it just may happen to be where if you updated the part number and forgot to do the description or vice versa, you're going to see these types of holds come your way. So we just need you to verify the values for each line item. Another part of the DFA check we're looking at are layout concerns for our production floor. In the example that you see there on the left, we have an 0402 component on an 0603 footprint. Due to the actual part size versus the pad size, we have a great concern with this because the part can misalign. It can rotate tombstone after it comes out of reflow, which costs you additional time and rework costs, because then we'll have to fix it on our end here. But if at the DFA stage we identify this issue for you, it could be a simple solution of you just upgrading that particular part to the 0603 component, and then that'll save any kind of additional rework that can incur after reflow. And then looking at the example on the right there, you have an 0805 component on a 0603 footprint. Although that part is placeable, it's not ideal if you're planning on going into production runs, because we're trying to give you optimal resolutions for your footprint on the board. So that's the type of recommendations, even though it's not a hold, it's something that we recommend for you and give you the option of, you know, go ahead and place it or go ahead and change it to an 0603 part. We're helping you in these type of prototype runs so that you can eventually upgrade yourself to do production runs. This is actually a type of layout issue that I see a lot with our DFA checks. And it just shows on the data sheet on the right there that the actual physical part should have a thermal pad, but on the left, that's the footprint on your Gerbers. The aperture for the thermal pad is missing. So at this particular time, we'll come to you and ask you, do you really want that thermal pad connected to your board? If that footprint is covered by solder mask, we can place that part as is. But if it actually is not covered by solder mask, then that will be a concern because then your thermal pad will be connected to those open vias and traces underneath. And then at that point, we'll have to contact the fab house and warn them of this particular issue. So we'll give you the option of if either you want to place it as is, or if you want to go ahead and change it to a different component that doesn't have a thermal pad on that particular footprint. And then on this particular layout issue, this part is the completely wrong size where the leads are not making any contact with the actual pads. Sometimes in a family of components, you'll have different packaging size. And so it just may happen to be where you pick the wrong package size, but we'll give you this particular hold and tell you that the leads are not making contact. We can't place it as is. If it's a critical IC that you must have on your board, then the only option is to redesign the Gerbers. But if it's in a family where you can choose a different package model, then you can actually give us the updated part number. We'll double check the footprint again and make sure that it fits before we go ahead and proceed. Another critical part of the DFA check is for us to verify the rotation polarity of your polarized parts on your board. And in order for us to do that, we're looking for the information in the data sheet. In this example here, it's a speaker where one of the leads is marked with a plus sign. But if you look at the footprint on the left-hand side, we have no silkscreen indicator whatsoever to tell us where to place that positive lead. So we'll capture these images and send it to you and tell you, hey, you're missing the positive polarity indicator on the footprint. Can you just identify that for us so we know how to rotate this part once the technician goes out and tries to install it? Another example of a missing polarity indicator on this particular IC, I don't see any pin 1 indicator on the silk screen. And so again, we'll capture this image for you and let you know, can you help us identify where pin 1 is on the actual footprint? You'll come back to me and tell me, oh, it's on the bottom left-hand corner or the top right-hand corner. And then once that's been established, we'll go ahead and add a marking on our end to let the floor know where to orient pin 1 so that we can place this component correctly. So we're going to go over some of the do's and don'ts so that you can successfully create your files and send it to your fabrication house and your assembly house with minimal issues. Here are the list of do's that I have. Just go ahead and take advantage of the free DFM and DFA checks on your actual builds. So if your assembly house or fabrication offers that, take advantage of it, especially for new designs. And then the next one is to read your data sheets. Also to use your fabricator's design rules. So if you are, if you've been using your fabricator's house for a really long time and you understand their rules, or if you don't, I would get in contact with someone and go over, the design rules that you need. And so that way you have it handy when you're actually doing new designs. And another important thing to remember is to ensure that the parts in your library have the right footprint. So if we give you feedback that the actual footprint is incorrect for that particular part, go ahead and make that update in your actual software right there and then. That way you don't forget. Another important note to take, to be aware of is to include notes in your README that are unusual, that are outside the standard. And some of these examples are if you have any requirements for cutting traces or adding jumper wires, or if you have the need for RTV, epoxy, or Loctite to be applied to certain components on your build, or if you just have some really sensitive components that cannot be washed, anything of that nature, go ahead and put it in your assembly documents for us to review so that we can make sure those go onto your production notes for the production floor. One thing I do see a lot that causes a lot of confusion or missed notes on our side is that the customer would put assembly notes inside the Gerbers or in the fabrication drawing. We don't actually look at fabrication drawings, so if you have assembly notes, please make sure they actually are in an assembly drawing so that we can review all of those and capture those on the assembly side. And lastly, I would suggest that if you have any questions whatsoever, any concerns, have an open communication with your fabrication house and your assembly house, that we're all on the same page whenever you're ready to pull the trigger on a new boards being fabricated or on a new assembly job. Elijah, do you have anything to add on your end for dues for the fabrication side?
Yeah, definitely. I'd like to, again, just emphasize that last note of communicating with your fabricator regularly. If you are using a new fabricator, or maybe you just haven't really contacted your fabricator, get in contact with them, know their rules, know their design rules, and the better relationship that you build with them, the more they're going to be able to know what to do with your design sometimes. And there's a few customers that we have that they stay in contact with us, so I'm able to just make the calls for them because I know most of the time what they want to do. And I actually get a lot of phone calls from new customers asking, hey, what are your design rules? And I'm the one who takes those calls and we'll explain it to you. So if you guys have any questions or on our capabilities, give me a call and I'll explain everything for you. And let's go over a quick list of don'ts. Very first rule is never assume that we understand your design simply because we have your Gerbers. Guessing costs everybody money, whether we as the board shop were wrong or you as the customer made an error, it's costing us money. And so the next one is don't copy and paste parts without updating your REFDES, as this can create duplicate parts. You don't want to be paying for more than what you're using. And then you don't want to change part numbers without confirming the new value and footprint. And last, don't forget to run your electrical rules check and design rules check. Those are huge parts. If you do that quick little check before we get your Gerbers, it's going to save everyone time.
All right, now we'd like to open it up to some questions for everybody that's been watching this presentation today. So if you have any, please ask them in the question and answer box, or you can also use the chat if you can't find the Q&A. All right, so our first question comes from Amba Prasad, and the question is, does IPC CFX improve DFM? So for those of you who are unaware, IPC CFX is, according to their webpage, an electronics manufacturing industry developed standard forming the foundation backbone of Industry 4.0. IPC CFX simplifies and standardizes machine-to-machine communication while also facilitating machine-to-business and business-to-machine. So I'm not real familiar with this. I don't know if either of our panelists are either. Chow or Elijah, are you familiar with IPC CFX?
I'm not familiar with it.
Yeah, I'm sorry to cut you off, but not on the assembly side, no.
Okay.
Yeah, it definitely sounds like a fab side, but I'm going to look into that and I can get back to you.
All right. There is if they're referring to IPC DFX standard, there is a 2231 as well. We've also got a comment here, which I think might be chiming in on our previous question from Thorsten, that simply states IPC 2581. Torj, were you just trying to jump in and help us out there, buddy? Yes, he was. All right, thanks, Torj. So I think perhaps maybe there might have just been a miscommunication there on my part. So Torj says this is similar to ODB++. Okay, so this is the IPC 2581 file format I think that they're referring to for transmitting the whole CAD-CAM file. which brings us to the question of what files do you guys like to get?
We like to see the Gerber 274X, and if not, then ODB++. We can run with those all day long.
All right, do you guys pull in the IPC 2581 file format at all that you're aware of, Elijah?
That I know of, no, that'd be something more on the sales side once they receive your Gerbers. Usually if it's something a little weird, they try to convert it before it comes to engineering.
Okay, and that is, I'm just going to throw one of my colleagues under the bus. That's something I've heard Mahir talk about quite a bit at the on the sales floor. So I'm pretty sure that's something that we pull in, and it probably the CAD and CAM guys miss that part of the conversation. So, so David, hopefully that answers your question. We've got the Gerber 274X, ODB++, and I'm pretty sure I've heard the IPC 2581 as well. All right, what other questions do we have out there? We've got a couple in the comment box from Tim Rebecki. How do you specify surface finish type on the pads, and how do you confirm that they are correct?
That's going to be based on your software that you're using for your design. It's going to differ, but basically it's a double check. You can even usually see it visually. Obviously you're going to have copper. You take a copper layer, throw it on top of your drill, and you're going to see instantly which ones don't have copper. And once you create your drill chart, it should be able to list which ones are plated and non-plated. And it's usually just a visual check, does more than enough.
So we add a layer to the, on top of the outermost copper layer to define that, is what you're saying, Elijah?
Yeah, you can usually take one of your outer layers and lay it over your drill layer and just kind of compare the two.
All right. From Lisa. Oh, this is our Lisa. She was wondering if the question referred to how do you specify surface finish? Like, are we doing ENIG, Hassel? How do we define that and send that to our fabricator?
Oh, that's going to be in the fab print. Yeah, like she's saying in that comment, you add that into the fab drawing, and that's usually the first place we look for that. It's usually in the quote also, so right away when we get the quote sheet, we're going to compare that with your fab notes, and if we see any discrepancies, we're going to ask you about it.
All right, thanks. From Donovan McDonald. Should I be providing the drill file along with ODB files? I usually leave a drill chart in the ODB file itself.
I'm sorry, can you repeat that question?
Sure. So the question is, where do we put the drill file?
Yeah, it's going to be either in your ODB++, or you can just throw it in your Gerber files. Usually they throw it all in one folder. I've also seen it, the copper layers and the drill layers in two separate folders, but either way, we look at every single folder and file inside that data package.
All right, so as long as the drill file is included. That does raise an interesting question, something that I ran into when I was trying to help somebody out a couple of weeks ago, and just really made life miserable. We had two drill files, and they didn't correspond with one another in some fashion. So are there dangers in providing too much information? What does that look like?
It's definitely going to create a hold, because I'm going to see that something doesn't line up. One of them aren't going to match with the data, so I'm going to question that. So, I mean, it doesn't hurt to send it, because again, at the same time, we do get a few instances where a lot of files are forgotten, and I guess I'd rather have everything than nothing. But either way, that's pretty simple to clear up. And I think something that helps, actually probably the last two questions together, is having a netlist file. If you have a netlist file and you send that, most questions that we have, whether it lines up or not, we're going to waive it, because that IPC file that you created confirms that, hey, everything on my side is working. I've double, triple checked, and this board is exactly the way I want it. That is going to be our kind of white flag of saying, hey, go ahead and proceed with the build. You don't need to put it on hold.
All right, from, I believe it's either George or Jorge Mar. How do you deal with solder mask defined pads to make sure all pad sizes are the same for a component?
Again, that's going to be in your design software. Something we do is we select one and use a select all kind of feature, and you can instantly tell where all those are going to be at.
So let me see, George, can you clarify, are you asking on the design software side? And if so, can you let me know what design software you're using? I might be able to narrow that down for you. Or if not, please ask your question a little differently and we'll try to give it a shot. All right, any other questions? I'm gonna go back through here and make sure that I didn't miss anybody here in the chat. And it looks like our chat's cleared, and I think we're just waiting on George. So if you have any other questions, we've got our panelists here for another 11 minutes if we need them. Please ask now. We want to make sure you guys leave happy. Also, while I have you here, please let us know if there's any other webinars that you guys would like to see, or if you'd like us to go more in depth on something that we've done in the past. All right. From Torge, if I have a design with different assembly variants, is it okay to provide one generic pick and place showing all components and then specify each assembly variant through separate variant specific BOMs?
That's a question for me. So if we get that information up front that you do have one main pick and place but different BOM variants, and you tell us that, so right now you're having, remember that compare that I showed earlier where we're comparing the reference designator in the bill of materials and pick and place? And so if you let us know ahead of time that there's different BOM variants and whatever's in your BOM is what we're actually supposed to be populating, then if we get that discrepancy that you have reference designator in your pick and place and not in your BOM, we'll just disregard that hold completely, but we'll also FYI you and let you know that, hey, these are in your pick and place, but not in this BOM, but based on the information you've provided for us, we'll go ahead and disregard these. And so it's just about communication. If you let us know that you only have one XYS and many BOM variants, then we will not put that job on hold for that particular reason. So the answer is yes, you can provide one pick and place with different BOM variants.
And Chow, since we have you, why don't you tell us very quickly how consignment works?
So consignment is when you are providing us boards and components. And so in those particular cases, we do offer turnkey services as well. And in the instance that you're supplying boards and components, we do have kit labels that we can send you that takes into account the overages that we do need due to attrition that happens when your parts go through the pick and place machine. And so if you follow those kitting labels and supply us the correct amount of components, we won't have any issues. You can also, for us, you can also turn in parts that are in loose form. And so I know most assembly houses requires you to send like a minimum strip of this many parts or parts only in reels, but we don't have that requirement. So if you have a small build with loose components, we can take that as well because we have a custom tray system in-house that allows us to use those type of parts in our machine. So we're not going to hand assembly those. We're actually able to put those parts through our pick and place machine as well.
Thanks, Chow. Amba, I see that you've written IPC CFX again. We're going to have to get back to you on that one, buddy. I think that's just a little outside of our panelists' wheelhouse and my own at the moment. All right, we do have more questions coming in from Tim Rebecki in the chat. How do you control during assembly that you do not use any MSD components that have expired beyond their out of package life?
So we actually don't keep any stock of components in-house. And so every time we do turnkey orders, we buy new from vendors like DigiKey, Mausers, Newark. And so we do not keep any parts in-house that can be expired. A lot of the customers require, like if they have control systems where they need traceability on parts, where it came from, the date of manufacturability, things like that, we can also provide you with those documents, but we don't keep any parts in-house just for that reason, because we do not want parts sitting in our facility.
And don't we get parts overnight from DigiKey?
Yes, we do. We order so much from DigiKey. We have orders come in every day, and yes, we do order daily from them for overnight shipping.
So there's absolutely no delay in getting your parts. By the time that the board is manufactured, your parts are, I mean, if they're available at the warehouse, they're going to be at Advanced Assembly. All
Yes.
right, we've got some more questions from George Marr, or Jorge. Sorry, I don't know which one it is. Oftentimes, the solder mask defined pads on ground areas are bigger than those in signal pads. My question is it up to the designer to specify pad sizes, or the PCB manufacturer should do this, or the PCBA manufacturer? I'll jump in on this one and then let the panelists follow along. That's really going to depend on what your data sheet says. Obviously, I mean, you've done design, so have I. You can't necessarily trust the parts that are in your library because you don't know who made them. And they may have just said increase everything 5%. They may have said keep everything exactly on the same pattern. But your data sheet is what's going to drive that. So go into your part library, copy out the part that's there, and then confirm it with your data sheet, or remake the part yourself. Chow, did you want me to read that again? And Elijah, to see if there's anything you wanted to add on?
Oh yeah, I can add on to that.
Okay.
I can add on something that is worth mentioning on that side. As far as the fabrication side, you can add that note in your README file saying something about your solder mask defined pads. That'll stop the hold. But on our side, as far as doing the DFM check, we just have it must be 2 mil bigger kind of thing. And so if it doesn't meet that, that's when we're going to put it on hold. But if it's in the fab note or the README file, it just says, hey, I do have solder mask defined pads, that's going to avoid your hold.
All right, from Torch, what's the best practice for solder paste definition? Do you need the designer to provide a stencil layer in the Gerbers, or do you prefer calculating the sizes on your side based on the raw pad side? This is similar to our last one.
So that's a question I would like to answer. And so what we are actually looking for is the paste Gerber, and what we prefer is a 1-to-1 ratio with the copper pads. And so once we have that, that's the minimum information that we need. And we actually have 2 My600 paste printers in-house, which means that if we need to adjust any paste deposits, we actually don't have to go and order stencils. We can just make the adjustments on our machines and say, based on what we've seen, because we do a first article run on your board. And so if we see any concerns about too little or too much paste, we'll actually make the paste adjustments on our machine right there and then go ahead and run the paste deposits on another board for you. So, and we do that based on our experience as well as far as the part type. So if we see a part that comes in and it has been a concern for us before, and we've developed a particular paste deposit, so the amount of paste that should go on this type of part, we'll apply that to that particular footprint so that we don't see any issues once it goes through reflow.
So for those of you who didn't catch what Chow just said there are no stencils anymore. These things, the paste is printed just like, I mean, as a crude example, just like an inkjet printer would print.
Yes.
All right, that seems to have cleared out all of our questions, and we're just about at 10:45. I would like to thank all of our panelists and all of our attendees for joining us today. We hope you found this webinar to be informative. If you have any further questions, please feel free to reach out to Chow or Elijah directly. We've got their information provided on the screen here. This is what they do all day, every day. So they're they're there to help you and make your life easier. Something like 95% of products go on hold for one reason or another. So essentially everything does until the designers learn what they need to provide. And sometimes that's a skill set that needs to be developed. If you have any other questions, feel free to reach out to them or anybody else in the companies. Everybody's real helpful, real happy to help you. And with that, I'd like to thank everybody and hope you all have a great day. Take care.